Hey everyone, Yalamir here. Uh, I am going live in kind of a strange time, I think, for most people from Europe or not where I am in the world. This is probably very late at night, but I just had some time and I thought it might be fun to share about something that I've been doing, which has been just really fun to do in the last few days, which is to create this C++ library called ResEmbed. It's an open source library that I just published a few hours ago. I thought it would be fun to talk about. As usual, like, subscribe, but please comment. I'll try to put comments on screen and discuss things if you want to. Since this was just released, as I'm going to be showing this, it's very possible that we will find bugs in the library, and I will fix them as we're talking. So there might be some live debugging happening. Yeah. So how's it going? I'm hoping you're doing pretty well. Okay. Just checking all the streams are working and everything. Okay, so let me move my face around and start to talk about what are we doing and what is the problem that I've been trying to solve. So one really annoying problem that happens in C++ coding or general probably coding has to do with resources, because, and I'm just talking as I'm kind of doing my own audio mixing in my ear and stuff like that, so that I don't overwhelm myself with level. But the idea is, in when you make a product, like let's say you make a game or a web app or anything like that, you're going to deal not just with code, but you are going to deal with resources. You know what? I'm just thinking maybe while I'm talking, I'm going to post a link somewhere on Discord, see if somebody wants to join. Yeah, first of all, hi everyone. I can see people joining on the multiple channels. I can see people watching on YouTube, on Facebook, on Instagram. So thank you for doing that. Feel free to leave a comment. I will be bringing comments on screen or discussing them or answering them, so that people watching on some other network, etc. Okay, so I'm just going to post this on Discord so people have a bit of fun if they want to. Okay. All right. So let's start to talk about why this exists and what is the problem that we're trying to solve. So in a C++ project, or again, if you're making, let's say, a game or an app, you might have a lot of just files that you have to load. For example, if you're making, an audio plugin, and we're going to talk about the audio plugin situation in a second, you're going to need, images. In some of our plugins, we're actually adding audio samples built in. We're adding MIDI files. We might be adding presets, just preset files. And you need a way to distribute those. And even if for example, let's say that you write some code that uses something that opens files, like in C++, you'd use something like fstream and you open a file. This works really well as long as the file is actually there, right? And if it's your machine, if it's your dev machine, then you can put the file somewhere, or you can have a script and it copies them somewhere, and then the file is there, and you can relate to that file somehow and read it or parse it, or you read JSON files or read the web page. But the problem is, for that to happen on a user's computer, that gets a bit dicey, right? Because do we know that the user has those files? Are we building an installer that puts those files on their machine? What happens if they delete those files by accident or move them around? So files on the disk, they're very useful, but they come with a baggage. They come with a deployment process that you have to think about. And fallback process, an error handling process, and all kinds of things that you have to worry about. And when you just want to build a program and send it to your friend, or even just send it to a user, uh, you might want a simpler version. Like what users ideally want and would have loved is that if you can give them an exe file or a VST3 file or something, and they can just use that without anything else, right? Because that's one file. It's very easy. Like there's no error handling. There's no multiple files in multiple places on the disk. And also it's condensed. If you think of like versioning, like if you say, well, I have to make a change. I have to create a new version of the plugin with this new image. How do I make sure the users get the new code of the plugin and the new image? So multiple solutions have come up in history to try and solve this problem. It's a known issue. So if you look at Juice, Juice is a famous plugin framework. They are using something like binary data. We'll show how that works in a second. But they have a solution where you embed the files, like your images and all that, into the binary so that the binary gets built and it's all included somehow magically. And that is a pretty good solution. Like I've been using binary data for a long time. I think it usually requires to write some things on top of it when you write a bigger project, but it's very good. There are other libraries that do that. Some of them have tried to collaborate with the build system somehow. Some of them try to provide a script or a scripting way so that, or sometimes you would have something where you append something to the end of the file after the build. So I was trying to create my, hopefully not ideal solution, but a solution that I think would work for most use cases, I think, and work for me. Just something that I've had to deal with resources a lot. I've had to think about how resources are deployed in terms of like, somebody on your team, like the GUI designer, creating assets, committing them to Git. Somebody has to build them, put them in the project. So I wanted something that is, generally speaking, hassle-free and very integrated in how we make the build and the code happen anyway. So let's dive in. So first of all, let's see if I can go here and show this. So this is the am I frozen? No, I'm still working, right? Just see that everything works. Let's move away from the screen. So basically, this is what this looks like, right? It's called ResEmbed. The link should be in the description. It's MIT license. You can just do whatever you want with it. And it's a wrapper around something that does code generation. We'll talk about that. We're going to review that. And a build system integration so that you basically have a one-liner in the build system and a one-liner in the code to make this work. So the idea is, for example, let's say you just use fetch content. This is a CMake thing to bring in external libraries. You bring in ResEmbed. Let's make it a bit smaller so that you can read the whole thing. So this is just standard CMake code to fetch something from Git. And you have an executable, and you can just call this one function that says embed this directory. And really, that's all you need on the build system level, right? This does all the scripting. This makes sure that things are going to link correctly, build correctly. The whole magic just happens, right? Because usually you already do this. You already do add executable, or you do add library or something in CMake, and this just adds whatever files you wanted into that target. And then in C++, the idea is that it's very, very simple. Like it's just this one include and something that says ResEmbed get, which gives you the resource. And we're going to dive into what that means implementation-wise. But let's start by building this. Let's go ahead and look at this example. So if I'm going if I was loading Resource Embedding right here, hopefully you can see me. I'm just hoping that this framing makes sense. So let's look at one of the most basic uses. Let's look at this thing called named, right? So this is an example. This is basically a similar example to what the thing showed. There is in this example project, there's a CMake file that just adds an executable and then adds a file called resource.txt. this is resource.txt, right? It's just a text file. It says some text here. And then all I have to do in main, right? In this case, I include the IOStream just for the printing, but I can just call ResEmbed get and ask for it. And this is going to give it to me and print it. Let's see how this works. Let's print this thing called, I think this is called named. So let's build this target, and it prints some text here. Let's say we make a change in the text file. Like I'll go to resource.txt. I'll change it to new text, not the old text, right? And let's just run this. This is gonna detect, let's look at the build system. The build system detected that this has changed automatically. It did this binary resource.c thing. We'll talk in a second about what this does and why. It linked it, and then when we were running it, let's look at the run result here. It prints out here some text here, new text, not the old one, right? And I can now just commit this to Git because this is in my source directory. I can commit this, and any build will create this. The resulting binary is literally just the one executable. We can take a look over here. Let's put it in my Finder so we can see what CMake outputted. It's called examples named. And this is it, right? This is the, let's make it bigger. So it just created this executable. It might have generated a bunch of code, but eventually it all got stuffed into the same binary. And I can just deploy this binary. I can code sign it. I can put it in a Mac bundle. I can write an installer. I can use this to create an audio plugin, which I will very, very quickly in this video. And there's no distribution thing happening. There's no need to worry about where this file is on the user's computer. This is generally speaking the interface I was going for. So it meant to be a one-liner in CMake. The one-liner in CMake was this little thing called ResEmbed, right? That's it. And then in C++, you include resources.h, and then you grab the resource. So it's meant to be streamlined. It's meant, other libraries usually require additional things, which we will talk about, that I was trying to avoid when doing this. But I was trying to do so that, you want to have a JSON file, you want to have an image, you want to write shaders, you want to write like some runtime code, you want to write JavaScript code. This is a good use case for JavaScript or anything related to a web page you're showing in your binary. Now, web UIs are a big thing. Yeah, so I'm just going through here to check a little bit of the activity and see what's going on. But yeah, this is the general idea, right? So let us maybe look at dive into the implementation here. And then later we'll talk about some of the more complicated examples, because this has actually a few use cases that are more complex. One of the complex issues that I was trying to solve for my projects, like for the Modalix projects, for example, is I wanted to find, I'm just going to roll back this change because it doesn't matter. I wanted to solve issues where, for example, you have libraries. So one of the problem with something like the juice binary data and some of these other solutions that exist is you write a library, and the library requires a type of resource, but it's not the actual resource. Let's explain. For example, let's imagine that you're writing a library that is meant to provide a different UI for plugins. But the design of the UI should look the same. For example, let's say you were talking about a licensing page or an about page for multiple plugins of the same company, like Modalix. So one way to do this is you could, create this. One way is you can create like a component or a widget or a graphical widget and say, in the constructor, I'm going to pass all these things in. I'm going to create this class widget, and here are the resources. But that sometimes makes things very wordy, because sometimes that system is very nested in many, many systems, and you might not always want to just pass that in. Instead, you can make the a library compile and link with different resources that you, the plugin, are going to provide, or you, the user of the library, is going to provide. So, for example, I have this thing here called shared lib. This is where I was trying to show this. Let's run this and see what happens first. So you can see in my list of targets, I have something called app A, app B, and app C. And these are all using the same code. So let's run app A, and it says this is from resources A, and app B does, this is from resources B, right? It's the different one. And app C is saying the resource is missing, right? Because that could also happen. I need error handling if the resource is missing. And the way this works is all these libraries are built from the exact same code. It's identical code. So for example, this is the library code. The library code is a beautiful library with one function called print resources. And in the implementation, it goes and asks for a resource called text.txt. So it's a resource by name. But when it includes it, it actually just includes the ResEmbed header. So the ResEmbed header does not actually know about the specific resources. That means that if this resource does not exist, this is going to provide an empty resource, and it's going to hit this error thing. And then let's look at the code for the app. The code for the app just includes resources.h if it exists, if we actually have the resources, and it calls it. I made another CPP here for a library which is identical for one that does not have the resources, just so that you can see what this looks like. Just looks the same, includes lib, includes resources, and calls the function. But the magic happens in the build system. So in CMake, app A says ResEmbed add and links against directory resources A. And this is just going to glob everything there. It's just one file in this case. ResEmbed add is going to grab resources B. And this is how we can create variants. So for example, I can create multiple apps that have exact same code without touching the code, just linking different resources. So let's say so for example, let's say I want to create an app that just wraps a web page. The actual C++ code can be identical, does not need to change at all. But this target can link in different resources for each one, and this would work. And this would work even with the library itself. Never has to actually link with those resources. The library can actually be built by another team, right? All the other team has to know about is that it requires this particular resource by name and by category, which is another feature of that library. Yeah, so this is the general idea for how this is supposed to work, and we're just gonna try and perhaps review the internals of this a little bit. Just going to check and see what's going on here, making sure that I'm on time. I'll take a drink. How's everyone doing? Are you hearing me correctly? Is everything working? I'm hoping audio is fine. I know this is a strange time to stream in for most people. All of my friends are asleep right now, so hopefully you would see this later. Okay, so let's talk about how this is used in actual products and in plugins, and then we're maybe going to talk more about the implementation. So for example, I'm going to show you some of the Modalix code, which I've recently converted all of the Modalix code to use this, because the previous things I was using, for example, binary data and CMRC, were just too slow, and I had to write all these wrappers around them. Some of them still exist. I had just to maintain compatibility, but I just wanted to remove all this stuff and get the extra performance. And so let's see what happens in a complicated project. Let's go to a debug builder or something, and let's choose something like. So I'm going to build something like. Mindset Drums. Mindset Drums is going to be a good candidate because it's a huge project. For those who don't know, Mindset Drums is a great drum plugin that we make with Modalix. It's an acoustic drum sampler. I'm not going to put the entire sample library as in the binary because it's massive. Like the full sample library could be even 25 gigabytes or something. So we didn't want to make a binary that large. So we did separate out the big sample library. However, we are embedding a lot of other smaller resources inside of this binary. And let's see what happens. I'm just going to run a build. You know what? I'm just using Ninja. Ninja is great. It's a good generator, but I'm going to switch to using Unix Makefiles just because it's going to give a better output and show what's happening. Let's disable this. Let's just use Unix Makefiles. Let's clean the build directory and reload this project. Okay, and let's take a look at what this does. Okay, so it fetched Resource Embedder. Should call ResEmbed, but this is the ResEmbed. It built the ResEmbed generator. Now it's doing some juice stuff as a part of the configure step. Grabbing Chow DSP, needs to configure Chow DSP. Good. So it finished generating the project. And now let's build. Let's see what the build is going to do. I'm going to click build here. Ooh, a lot of things are happening, right? A lot of text on screen. So first of all, it very quickly ran through a lot of resources. We can talk in a second about what this did. So let's review what this did. So if we go into the plugins folder into Mindset Drums, which is right here. So there's actually multiple resource targets in this project. One of them is this resources folder, which has a ton of things. Let's open it in Finder so you can see it. Right, it's a massive library. It's got fonts, IRs, preset, schemes is all kinds of like UI, JSON files, SVGs. Overall, this library is 64 megabytes with 451 files. If you can see this, it might be a bit small, but that's what it says. It's like it's 451 files. Now, this is not the only resources that are built as part of this. This actually builds something from another folder here, which is the MIDI files. So there's another folder here called the MIDI files, and this has another 256 just MIDI files, for example, the Doron-Giat, the drum that template recorded, right? So these are a bunch of just MIDI files, a lot of MIDI. So what this does is this actually globs through all of them. It just finds them in these specific directories that we pointed to, and it adds them to the binary. And let's see what the build output looks like. So you see all those things. So first of all, the blue stuff, you see it's going to say embedding, right? So it's going to say it's embedded all these files. Look at all these names, right? Dave growls.midi, shuffle blues, bluesstarter.midi, right? bluesrockets.midi. So there's a bunch of just different MIDI files. If you're going to move forward, then you'll see there's a green bunch of green stuff. The green stuff is it actually compiling the generated C code, because it generated C code. So it compiled them just automatically as a part of this process. Then it did those a million times, even though it did it pretty fast, as you could see. And then it went and embedded the same things for all these PNGs, right? Here's an SVG. Here's a bunch of resources that it just implemented. It just took them away. And then eventually, after it finished all the generated stuff, which really took just a couple of seconds for almost 1,000 files, only then it switched and started building all these, MM and CBP files and the actual code for the build. Then when it linked it all together, it built, in this case, it's a standalone version, You can see what this looks like. Let's run it. Oh, it might think that I changed something. So here's the cool thing. If you change one of the resources, it automatically knows to figure out that something has changed. And here it is built. And now everything you see here, like for example, all these images, which is multiple images of the actual drums playing and the logo of Modalix and this background image and all the MIDI files that you get, all of it is actually loaded right into the plugin. There's no installation process for this. Even if you open this plugin and you have nothing other than the VST3 file, this is just going to work. You don't need any kind of files. You do need to download the big sample library, but it would still load. It would show a good UI. There's not going to be any fragmentation in this thing. So that's how we're using those projects, right? We're embedding them in the build, and we embed them in the code. And the Modalix stuff, there's a few other calls. Some of them are now redundant because I've added this library, but the way it works is if I'm going to look at the Mindset Drums CMake, it's calling this thing called add resources folder. And add resources folder is just a wrapper. It does some command line things just to match with the way it used to be called with binary data. Now probably not needed, but whatever. And then it calls ResEmbed add, right, which we've seen. And then later in the code just has to include this thing called include binary data. That's all it has to do. By the way, this is something that's a macro that used to be needed for Juice, but is not needed anymore. So I can probably just remove it. I'm just keeping it here for backwards compatibility, but I can just remove it right now. And later, you can do really cool stuff. For example, the MIDI files is something that has a runtime information so that it can check the whatever MIDI files existed in the run of the plugin. Let me explain how this works. One of the cool features of this thing, let's see if I can show you how it's the get binary category. Okay, so one of the features that I used to write that in my library, but you can do something like get category. You can ask it at runtime which resources exist in this category. So I'm going to put something in my build, for example, a new MIDI file, and then at runtime, the code can say, tell me what's available in this category. For example, tell me all the MIDI files so that, for example, we can have an artist commit stuff to Git, like MIDI files. They do not even have to touch the build process. They do not have to touch the code in any way. They commit these MIDI files. My build would know about this because it globs through this directory. And then when I use this thing called get binary directory, which I'm using here in this MIDI player dropdown, right? So this is what basically this does. It says get binary category. And this just globs through the category called MIDI files. And it adds the menu item for them, right? This is basically what this does. So like when you see in Mindset Drums, this beautiful thing called, let's take a look. Give a second to load the sample. So this is a beautiful thing. Not this, but this is called, right? All these MIDI files, right? Those are queried from this list that is populated by the build. Let's debug this so that we can see what this does. For example, let's do something like std cout, or else there's dbg. It's the choose debugger dbg cat binary dot first. That would be the name. Second would be the contents. So let's see what this does. Let's run the app. Notice something very nice, by the way, which Juice again does not really do, is that other than the one file that includes the resources list, you really don't have to you really don't have to relink this library code. You just have to recompile the one file, or you have to relink it, but you don't have to recompile almost anything beyond the one file that changed, which is the one that holds all the resources. So let's see what happens. I'm going to click this thing. Oop, here it is. Here's everything that the binary reported, right? You can see things like Malian, right? Mike Malian grooves. So let's see what happens, during development. During development, we're changing them, right? This is not a static list. During development, we might get, new MIDI files from Mike Malian tomorrow, right? So what we're going to do if that happens, I'm going to go to the library where I have these. Let's imagine that, let's go, I'm just going to manually go to the folder, right? Let's say that a new file came in, there's a file here called basic snare. So I'm just going to copy paste it and call it, let's call it something like, this is something like basic, new, basic. So, generated new MIDI or something. So I just add this. And when I run the build, this is going to detect that something has changed. It's going to detect what needs to be rebuilt and all that. And let's see what happens in my list of MIDI files. It's just loaded. In the MIDI files now here in basic, now there is generated new MIDI, right? There it is. So the idea is that it makes the process of working with resources very streamlined. The idea is that you can request something, or you can just request a category. You don't even have to request a specific resource. You can request a category of things like MIDI files. And then the build at some point has to just give you this list of MIDI files. And those are kind of separated. This MIDI player, for example, is in a separate library than the plugin. It does not even know about which plugin. I can actually build multiple plugins or multiple variations of the plugins with multiple MIDI resources. And those things kind of really help me scale up the production. Yeah. All right. Any questions so far? All right, so let's review a little bit about the implementation of how this works. So first of all, let's just take a look at the generated code. So if I'm going to go into my build folder, which we just built mindset drums, right? So I'm going to go into my plugins, mindset drums, generated. Here it is. Okay. So let's see what this generated. You see, it created a folder called mindset drums binary data generated. It's a big folder. It's got a bunch of stuff in it. But eventually the user is not going to care, right? This just these are all intermediate files, right? But let's see what this does. It created two things. One is a C file, and I actually very intentionally made it in C and not in C++, because there's a little bit of overhead whenever you're invoking a C++ compiler. It's very small. It's very small. It's just like a second of invoking that compiler. But if you're building hundreds or thousands of files, which we do in these projects, it's just an annoying build time. It's just some extra build time just to have C++. So what I did was I wanted to do something that compiles as fast as possible. So I created a C file in the generated code that has nothing but a single array, const unsigned char. It has a name for it. And notice there's no includes. 0 includes. There's nothing. There's no functions here. There's only another variable with the size, but that is it. So the idea is that this is something that is, even though even though this is kind of big, like this could be hundreds of lines of just binary. The idea is that this is something that the compiler would have as little work as possible to process through. Now, there are a couple of other elements that make this whole kind of magically work. One of them is that even though this is in C, there is a little bit of a C++ code that's generated, and this is this little thing called binary data.h. And what this is this has to generate two things. One, it has to create a static variable, which has to be in a namespace to be unique. So but it's a static variable, and it's to create a function to grab these resources. Then the CPP file, first of all, it's going to do this like external linkage. So here we're creating this external linkage that can link with that C file, right? So this is how eventually we know the two are the same one, because this CP file is going to ask for a C linkage of all these different C arrays, right? And these just has all the names, blah, 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 binary data, some number and size. But then it also generated this very nice list that has some additional information, like the name, like the name of the resource, for example, the name of the font, right? This is a font, and the category. These are all just in the same category in this case, but there could be multiple categories. So, and this is how eventually this gets registered. We're just going to go through this whole process. So what happens is when you do this, and when inside of your project, you're doing include binary data.h, what you're doing is you're initializing a static variable, a global variable. This has to be static, by the way, for a technical reason. And then this initializer object is creating a constructor that calls register entries with this vector of entries, which we've just seen, which is the list of data. So what it does is that once this happens, it goes to the map. The map is a private, kind of a private storage thing, and it stores all this beautiful data in it. And the actual what the actual map holds is a map of these categories, and then which also has a map of these data pieces. It's a two-dimensional map. But eventually, it only holds this little thing called a view. A view is something that's based on a C++20 stood span. And span is basically just a couple of pointers, or in this case, a pointer and a size, or a pointer to the start and a pointer to the end. So just basically just a couple of pointers. So it's the smallest data object that can be. Like you can literally just copy this data around. It's just a little bit of memory address of where all these things are. And then when you use this, all you do is you go to the map. You say, hey, give me this object. The object is just the pointers. You can store this object. Those pointers are going to remain stable. You can just store them somewhere if you don't want to keep searching the map. And then you could just read. The read from the data is as fast as possible because this is just memory. This is basically just memory, and it's going to allocate. It's going to point to the static memory. Like if we want to look where the memory is, this is the memory, right? The memory is just going to be the static thing that is a part of the binary. So this is really what the magic of this, right? The library is doing all this code generation and build system integration, blah, blah, blah. So eventually, when you want the data, you will have a very fast pointer to static data in memory. So This should hopefully make it very very fast when you want to access data, right? Uh, the data, you just have a pointer. You can immediately go and access it. You don't need to allocate memory for it. You don't have to. I've seen libraries that tries to like unzip it into RAM or something. You don't have to do this. This is just you could just like this is just static memory inside of your binary. Like you don't have to allocate heap memory for this. You don't have to allocate like additional memory beyond what's allocated what's allocated inside of the binary itself. So yeah, so hopefully this would explain things of why we need this. We need this because I wanted to do this compile time thing and this resource generation thing, but I also wanted so that when you use this, and let's go back to just the examples of how this is used. So I wanted that when you use this, you just do this ResEmbed get by name, right? It's very simple. This object, by the way, would let you do a bunch of stuff like this object itself if you're going to get it. So it's going to be like auto res dot. Right. This lets you do something like res dot to string, but you can also just get the begin and end. So you can for loop over this and go through the bits. Like I can go through like it's like a O2C res, right? And this would just give me the individual chars. Like I can just go instead see out. Right, if I want to see the individual bytes, let's see what this would do. It's called named. Right, so these are just individual bytes. In this case, this is text, so the bytes are the individual letters of the text file. But you could pass this, like let's say if you have a library that calls that loads images or wave files. Usually, it can take the data, like it can take the the void star address and the size, and this lets you have it like you can pass res dot as raw, and this would give you the const void pointer of version of this, and this is how you would pass it to some external library like SDL, Juice, whatever that reads and interprets this memory. So it's very useful. You can you can store this, like you can decide that, like if you make a struct, it's called I don't know, my resources, right? You can have a member of this. You can say the member is ResEmbed data view, res, and you can initialize it with this, right? So you can store this somewhere, and you can say, O2 resources equals this, right? And then reference this somewhere else in your code, right? Just pass this to functions. This is totally fine. You just grab it once. You can grab multiples of those, right? You can say, well, this is going to be this resource. This is going to be res2. It's going to have another resource in it. Like we mentioned, we can also dynamically grab all the resources. We can also do something like O2 all resources equals ResEmbed get category. I think the default is resources or something. So, and then we can do something like, for loop over this, for loop over res all resources, and each resource would have the first would be the name, and the second, and it would be the data view. So it's very, very useful. It's just very ergonomic, simple to use, and yeah, hopefully you will find some use for this. All right, so this is basically it. So as we said, this is in, let's see if we can find a link again. Looks like this. ResEmbed on GitHub. Start this if you can. It was just uploaded a couple of hours ago. Take a look at the documentation. There should be very, very simple examples in how to do this, including how to do the whole CMake fetching thing, the package management. This should all be handled with these couple of lines. This is the C++ stuff. You can also build the examples if you want to. I've tested this on multiple platforms. So if I look at my GitHub actions, um, let's look at the actual actions. Um, so this builds from, it's very, very cross-platform. And if it doesn't work on a specific platform, please let me know. But for example, you'll see that I'm building this now for um, Linux, GCC, Linux, Clang, Windows, MSVC, Windows, Clang, Mac OS, and iOS. But this should build for almost anything. Because it integrates with the build system. Unless I have a bug or something, this should really work if you're using this for Android. Should work if you're using this for any kind of like embedded systems. I think Arduino is using CMake, right? So this should also work for that. You should be able to build it for Raspberry Pi, ARM devices. I've tried it in ARM Windows. It works very well. So the idea is that it's something that kind of like pain-free. You should be able to, a resource that, this, you add these couple of lines. It's MIT licensed. There's no cost to this. Yeah, hopefully this is useful for some of you. And, if it's useful. And yeah, I think that's it for today. Have a good day, everyone.